Okay, why don't we go ahead and get started? So at openQSE Day, wow, that was not that long ago. Last Friday, we had a lot of great discussions about a quantum resource interface. Um, Tani-san and Mateus, and Doug gave us an update on QRMI, QDMI, QFW activities. We heard some very interesting things from NVIDIA with respect to Slurm and their new HRES. Um, then we also heard some very interesting things from other workload manager developers or vendors, producers. Cameron was there from PBS. We had Gabor talk to us about LSF, and Vanessa and Dan. Oh, actually, it was Vanessa who did all the talking. Gave us an update on the Flux activities as well. Michael gave us a perspective. Michael Sandoval, I think he's on. Yes, Michael is on. Gave us a perspective from the Oak Ridge operations team. And unfortunately, we ran out of time and we were not able to give Tim Osborne a chance to tell us about the analytics and monitoring team at Oak Ridge. So I'm hoping that we can discuss that today, as well as perhaps start talking about some of the milestones we defined. Of course, we all have our day jobs, so the milestones we do define, I certainly hope we can align them with your day jobs, okay, and the companies that pay you, okay, because of course this is an open community effort, and we are not paying you. Okay. So hopefully we can get priorities aligned. And I am hoping that the discussion with Tim will help guide us in our efforts to really understand what kind of accounting information, what kind of general data should be shared with users, and what would be most helpful, and what structure with the workload managers. I assume this would be Slurm would be the most helpful in integrating. Okay, so Tim, would you like to take it away?
Sure. Let's see if I can present correctly.
Okay.
Sure.
Yeah, kind of hold your breath for a few seconds when you
Yeah,
hit
that's
that
the way
share
to do
button.
it, right?
Yeah.
It's not doing it right. I tried to start it and then share, and it doesn't want me to do it that way. Share. Come on. I'm just going to share my screen and not present if that's okay. It'll be
Sure.
big enough.
That should be fine.
All right. There's my almost. There's my camera. Maybe? No. There we go. Hi.
Hello. All right.
Okay.
That worked.
So
All right.
I'm not just going to talk about the analytics and monitoring team here at Oak Ridge and how we do it, because I think Quantum's going to end up doing it a little bit differently. So I wanted to just talk about analytics and monitoring and then kind of Quantum operational data. So what is operational data? That's really what I'm going to focus on this whole time. It's data produced by a system about that system. Right, so for standard clusters, that's going to, like for CPU, GPU based, it's going to include power usage, memory usage, network usage, CPU, GPU, temperatures, job statistics, things like that. So some of this is going to be similar when we go to quantum, and some of it, I'm not a quantum guy, so some of it I have no idea what it's going to be, but that's okay. So why do we want operational data? There are kind of three main routes that we need operational data for. So the first is the operations team, the people who work on the system, they use this data to diagnose the problems. The second one is user support teams use this to diagnose job problems for users. Michael's team actually uses this kind of regularly. And then third, researchers use it to understand the system and influence next generation systems. So those are like the three primary uses for why you want operational data for a system. And then I'm going to show you all some pretty pictures of like some of the dashboards that we have for Frontier, right? So this first one, this is kind of job related, right? So here's a job ID, you know, I took off the user and project, but it's running, it's using this many nodes, right? I don't know how that's going to look on a quantum system. It's using this many cores per node, right? It hasn't exited yet. It's been running for 10 minutes, things like that. So that at a glance, right, they can look at their job, or the UA team can look at this and say, oh, this job is in a good state. Things look good there. And then over here in the bottom right, we have like a particular node, and we see what the temperature is on that node for the CPU, what all the temperatures are for the GPUs, right? And this is the same view, current, things like that. We also have a view to look at that for power. I just didn't grab that one. So this is how much RAM we're using, how much CPU load, etc. Okay. And then this is more what we might look at for like longer term, right? So this is like a job's total power. The average is in green, and then the yellow is the GPU power. And then down here is the blue CPU power. So you can tell that for this job, right, the GPU's kicked on, did a lot of work, came off for a second, went back to work, etc. And then here we have the GPUs 0 through 7, so all 8 of them, this is their temperatures throughout a job's run. And then this one down here, this is a networking graph. It's not a great one. You have, I don't remember if it sends above or receives above. I think it sends are above and receives are below. So how much network traffic they're sending, where it's coming from. So these things can be pretty useful to people who are looking at jobs. Just wanted to throw those out there so everybody could kind of think about, okay, that's what it looks like in a traditional cluster. It's going to look completely different for a quantum cluster. But why I'm really excited to talk to y'all about it is operational data analytics, y'all. Like this was created on the fly by every HPC site since Beowulf clusters, right? Operators needed to know what was going on with their systems. And, you know, back in the 2000s, they didn't have all these nice, easy ways to display it. So everybody was doing their own monitoring and then making their own visualizations. It was really, what did the system administrators think that they needed to share or to see? That's what they would make. They would only monitor what they thought they needed to know about. So basically, whenever they would have a problem, they'd start monitoring that problem after the fact, generally. And then they would keep monitoring it forever. The negative to that is, since it happened kind of across HPC sites, there was no standard written for these operational data analytics, right? So do we take temperatures in Fahrenheit or Celsius? That's a silly example, right? But what do we call power? Do we call it power? Do we call it PWR? Right? And why this matters is then today we've gotten to the point of AI and machine learning, and it's really hard to take a data set from one data center and compare it to a data set from a different data center. So, right, if you're trying to train an algorithm, you then have to take this data set that we're actually releasing one from our group for Oak Ridge. It's going to come out with SC, but it's going to have for 6 days every month, I think it's 6, it's going to have all of the jobs that ran on those days and like their temperatures, their powers, and things like that, so people can use it to research. But if Berkeley also released a very similar set at NERSC, it may have everything labeled a little bit different. And so then people have to take these and they have to change the labels to be what they want it to be for their training. And that's really annoying. So if we can talk about it now with quantum, we can come up with a standard, right? And it's really, you're going to need commonality between vendors. It's not just between sites, right? So that's what I want y'all to do now, right? Like we can develop a standard now. And that way researchers and manufacturers and anybody else who wants to compare that data site to site can pretty quickly, versus currently for HPC, it's a bit of a pain. Woon can tell you about that. The rest of my slides, so I actually reordered this. I was going to save this for the end because the rest of my slides are about what we do with analytics at Oak Ridge, but I can keep going into that. But do y'all want to ask me any questions about any of this yet?
Tim, you said something about SC. So were you saying that the common format or standard will be announced at SC? I wasn't.
No, it's not a common format. Sorry. My group, the analytics and monitoring team here at Oak Ridge, we are releasing a data set for 2024 and 2025 frontier data from every month. Jobs that were and their associated.
Very cool.
Yeah.
Okay. Very cool. Okay.
So we have a question. Claudio?
Yeah, Tim, thanks for the introduction with these slides. I have a few questions about the first one is about the what do you usually use behind? Probably it use Grafana here, but what
yes,
do you
these
use
graphs are Grafana. Yes.
Yeah, what do you use below Grafana to collect this data?
So that'll be my next thing I'm talking about.
All right, sure. Great. And another question is, these are somewhat high-level data, but would you also be interested on low-level data in terms of granularity? For example, here we are talking about quantum resource interface. Would you be interested on, for example, measuring from the perspective of the workflow, the time, the resource consumption from the perspective of workflow, for example, memory, performance, and also, for example, measuring performance of this data also from the vendor side, taking out the workflow manager so that you can compare vendors to vendors, not workflow managers to workflow managers. Because you mentioned about a side comparison, but there's also some these small parts that I call it granularity. So, would you have any thoughts on that? Maybe you're going to cover that later.
I wasn't exactly planning on covering that later, but we would definitely want to be able to compare vendors to vendors, as well as workflows to workflows. Woong, do you want to talk on that a bit? Woong is a researcher who uses our data more than I just I don't just collect it, but we are in charge of collecting it. Woong uses it for all kinds of research, so he might have good thoughts there.
So, can you hear me?
Yes.
Yeah, Teams wouldn't let me talk. Anyway, okay. So yeah, so that's a definitely interesting point. So I think operational data is like converging to a more holistic view of the center and application included. And like so the low level application, when you mentioned that, I was wondering what it was. I think it was almost akin to like application performance monitoring, if you will. So the behavior of the application using the resources, those are critical elements that we do care. I think it will show up in Tim's like presentation. That has been one of the key pillars that we think it's kind of the future. And workflow is not something that has been explored that well. There's a lot of hurdles to get there. It will be nice if Quantum will be a good vehicle to kind of spearhead that workflow monitoring aspect of it, like just having this holistic view of multiple systems interacting each other's, because that's the first element that goes beyond the one single HPC system, if you will. So that's a very, very interesting point. But it's what I'm trying to say, it's not happening right now, but it's something that we do care and we think that's the future. So yes, we're definitely interested, I think.
Okay, thank you.
All right, any other questions yet? Okay. So how does Oak Ridge gather their operational data? My group likes to look at it kind of like the water table. So we have a whole bunch of sources from across really anywhere, right? So these are not just the systems themselves, but it's also coming off of the storage systems. We have data flowing from them. We have data flowing from some users that want to send us data. So all of that data filters down into a Kafka instance. And then we pull that data off the Kafka instance, and we'll either put it into, we call it Delta. So it's Victoria Metrics, or it's Druid, or it's Elasticsearch. And those are what's driving our dashboards. We are moving away from Druid and more toward Victoria Metrics. And we still use Elasticsearch for like log data. And then we also dump it into the Ocean, which is a Minio, why did the name just escape me, right? But an object store, sorry. So that researchers can get to it. We store Parquet files that they can get to read all that raw data back in. So this will kind of summarize it a little bit, but then we maintain the raw. So to talk about our sources, so how the data is collected is really unique to each system. And my team doesn't care, right? So system operators, they're going to use the provided monitoring, ideally, that the vendor gives them with their system, or sometimes they're going to homebrew their monitoring if they don't get exactly what we want. And on Frontier, we actually have both, right? So Slurm uses some monitoring, so we have stuff coming from Slurm. HPCM, which is an HPE product, they have monitoring for all of their systems. So that's kind of like that's where the temperatures, the powers, the telemetry itself comes from. Slurm sends us the job data. And then on the storage systems, we have our storage sysadmins have written things to pull that data and push it to our Kafka instance. So everybody just pulls from there and dumps it onto Kafka, which generally people think, like, we've been doing this since 2018, I think, and people like doing it. It's pretty simple for them to do because it's not hard to write to Kafka, and kind of every language can do that for you. So that's what they do. And then from there, we take it off the Kafka bus and kind of manage it for them after the fact, so they don't have to worry about all these other things. So what is Kafka? I mean, sorry, I just kind of talked through that, but they just publish there, right? And they don't really think about it. Kafka is a message bus, and they don't have to worry about it after that fact. And we have a lot of data flowing through it. We bring in 4 terabytes a day of data that flows through actually a pretty small Kafka cluster. So it's been really a great workhorse for us. So then our next system we call Delta, which is really 3 different systems. These are all databases. They reformat the data that's in stream to be available for visualization, right? So Victoria Metrics is really good for for telemetry data. That's for metric data. It can roll it up if we want it to, right? And it can kind of keep it forever so that you can look back and say, okay, well, how was this machine behaving a year ago, right? Looking at just that machine. Or you can still look at jobs from a year ago if you want to, things like that. Druid is for more like real time. Really, we're replacing Druid with Victoria Metrics, but that's still in process. And then Elasticsearch, that's where kind of your string data goes, because it's Victoria Metrics is not for storing random strings. So if they want to look at logs and things like that, they can look back at Elasticsearch for that. And then finally, things end up in Minio. So that keeps the data available long-term for research, and it's usable from data analytics applications. We've done a lot of scripting on our side. Like, this is where we pulled the data from for our 2024 and 2025 job data set that we're going to produce, or we're going to release. So that all comes from the Minio portion, which is really good at just keeping it forever. It versus the Elasticsearch, which is where we used to keep metrics, storing it in Minio is about a 10x data reduction. So for very long-term things, it's been worth it. We compress it to Parquet, and it's very good at that. So that is what I had to share. I think I had 10 minutes. I probably went over, but yeah.
So Tim,
yes.
If you could bring up your previous slide, 15, I think.
Yep.
The entry point seems to be Kafka, but do you also have systems that, for example, write directly to Parquet format?
We don't manage anything that goes directly to Parquet. Actually, with Quantum, we've been talking about them going straight to Victoria Metrics, because
Okay.
Victoria Metrics is very Prometheus friendly, and they already had everything in Prometheus. And so they were telling us, the vendor said it might be easier just to send it straight to our Victoria Metrics.
I see.
Woon?
So you would prefer that if the quantum resource interface just stream things into Kafka then, or
That we're good either way. The reason,
Okay.
so if people tell us, hey, it's going to be easier for us to push to Victoria Metrics, that's fine with us. We like to put it on Kafka because some users like to just pull it off. Actually, we're talking to the rats. I don't know how to put that in regular terms, but like the accounts team they're going to start pulling job data off of Kafka for keeping track of the jobs that are running throughout the day. That's like a current project that we're working on, because currently they just summarize jobs from the previous day on the web for users to look at. So for them, pulling that off of Kafka is going to be easier.
I see.
Yeah.
I see.
So,
Okay.
Woon, did you have a comment?
Yeah, it's a comment. So, the Parquet files are really for archival, and one of the characteristics you lose if you directly go to Parquet is the real-time aspect of it, because you have to batch and store it. So, directly doing that in that way can be really helpful if you're this like one single site that has only one single system. That might be really helpful. That goes directly into Minaya, but in our case, we want it to go through our bus first, so we can do those real-time things as well as store it, like archival, if you will. Now, that does not mean implementation-wise we will not appreciate the implementation. It will be really nice if we have a nice Parquet exporter, if you will, an implementation that we can deploy on the back end. But it's not necessarily something that we want. Like, for example, if there's only Parquet files, that's going to be a problem, for example.
I see.
Yeah.
I see. Okay.
Yeah. So Parquet files, they don't go to your Grafana dashboards well. Yeah.
Oh,
so if you
yeah,
only
good
had
point.
Parquet, you wouldn't be able to visualize it
So,
very easily.
yeah, one thing about Parquet file is it's a compression thing. It's column oriented. It's column oriented. So you have to batch fair amount to be effective. And if you're like you have to batch for the scale of a quantum system, I think you have to batch for about like a month. And within that month, you can't do anything with that file, for example. To put
Okay.
easily, yeah. So you have to have some intermediate system that deals with a different kind of modality of a data stream. That's exactly what's happening here. Various sources, event stream, you have a streaming data set, but that won't solve the storage problem. The storage problem will be solved by the Mineo. That's the reason why we have this a little, you can say convoluted, but it's a natural progression of many different sites, if you will, because they have served very different needs at each very different points. So I think this, yeah, I really love this view. Like this is the first time I see this slide, but yeah, that's kind of how it works at our center at the moment.
And we certainly trust your experience, because I mean you guys have been managing systems for a very, very long time. So and many systems.
Michael, did you have a question?
Yeah, I was just gonna give a little context of what Tim alluded to with the vendor we're working with is actually the IQM system that we just brought on site, right? So even though it's been online a couple months, I think we'll find out a lot more information on this front as Leah and Tim's team gets to play around with it more, because it's nice they even have a Grafana dashboard of their own. So we'll definitely get a lot of lessons learned from the IQM machine that's on site.
Oh, great. Because one of the big concerns I think that we'll have is how do we standardize on the information? So we would definitely appreciate it if you could share the lessons learned, so we can kind of follow that.
Woong already raised his hand.
Yeah, just a comment on comment on that one, because the standardization of the thing, I think one thing we have to, I'm interested to know is like how can we incorporate requirements from different parties who are interested in the quantum data set, because that's one thing we do know, like the data is multifaceted and multi-consumption. So there are anyway, so research perspective, operation perspective, accounting perspective, those are all very different. That's what I see we see from like all different sources. So like combining those things and defining but there's a possibility where we have a minimal set because that occurs many different times. So I think that might be a discussion which I was like originally interested by this openQRI effort. Like there's a chance we can kind of define that by engaging as a quantum scientist, a quantum researcher, what do you care about? As an operation person, what do you care about? It's accounting, what do we care about? What do you want to allocate our systems with or for? Things like that. So yeah, I just want to make that comment in because it's not only one requirement here.
Yeah, I think that's a really interesting point. So the operational data analytics community, that's something that Woong and I are part of. We actually have a workshop at SC, right? And most of the time we think of it from an HPC side. It would actually be really interesting. So the papers are still open. They don't have a long time left. When is it due, Woong? Do you remember off the top of your head? It's like
next Wednesday.
Next Wednesday? Okay.
Yeah.
Right. So if we can throw a paper together, even if it's just a short lightning talk worth, right? Like to say, hey, quantum also needs a standard and we need to have this conversation. That could be a really interesting topic for the workshop to talk about. So
yeah, because I was just about to ask, so when you were talking about different, I guess we call them personas, right? So I'm wondering if we could just start there. Like, what are the different people who would consume things, and just start the conversation there? Because I think that'll then direct us at least in the right start. So, okay. Oh, but Wednesday. Ooh, that's pretty tight. But okay.
Not tomorrow. We have 8 days. Come on.
That's true. That's true.
It's very tight.
I
know.
What's the workshop called, Tim?
It's called it's Operational Data Analytics Workshop, I think. Is that right?
HPC Operational Data Analytics Workshop. This is the first, yeah.
Why'd we throw HPC in there? I think quantum should be in there too.
Yeah, we agree.
That's what that's kind of what our mindset is, though, right? Because that's what most of the data is right now. But I think there's a lot of experience in that community that can help this discussion.
Yeah, so. I agree. Yeah, I agree. Okay.
So one question. I think ORNL will be operating different modality quantum system. Do you have any, maybe this might be a little bit early, but do you have any idea how to differentiate those in different modality information? I think the stream of the data itself would be different.
So I will say right off the bat, we have absolutely no idea how that looks like. So what we're really looking for is the engagement with the experts who knows those things. So because our experience for the data sets, even though like I think one thing you should notice, like we don't have any standards until now. Just because like the systems always evolve. So like getting one particular topic, for example, a power or cooling or application, that is a investigation in itself. So the engagement really looks like we have to engage with the vendor and the people who wants to monitor the system and wants to do research on the system. I have to identify the personas and these user stories or user journeys, and then take that to a degree that we can translate into data sets that could actually enable those things. And those are really upfront investments. That's the initiation I think we have to start right now. And again, we don't have no idea, but I think it's a good pool of people here that has expertise from a variety of aspects of it. So we can really discuss, again, define the user personas, user journeys, and what fields actually matter and how they translate into either revenue or some kind of form of like achieving the user journey, if you will. And then we have a set of fields that really matters, and that's kind of the way how I think we would go. Modalities, again, it's something we don't know. Like I would assume they all have different characteristics, different operational conditions. Superconductors and the quantum dots, those will be very different. So yeah, we are eager to learn.
Mm-hmm. Yeah. And at least for right now, all we have on site is the IQM machine, right? Technically, there's quantum brilliance, but that's technically a loan, so it's not ours, right? So at least for right now, what we have on site is just the single IQM system. There might exist a River Lane error correction box somewhere else, which we might be able to get information from once that's hooked up to IQM. But other than that, we have QCup, but those also aren't our machines. Those are cloud machines too. I'm curious if like what we could do through that, but that's a side thought.
Yeah. So I think what's interesting, right, I thank you for bringing that up, because like the idea is that's why we need to get all the different vendors talking, right? Because even at Oak Ridge on the HPC side, right, we have multiple different HPC machines that if they were from currently most of them are HPE, if they were from different vendors, right, and they presented completely different metrics, then basically I have to go in and rework all of these things depending on the system. Maybe I need to return something differently here, right? Like I have to work in all these shims to change from X to Y so that everybody can look at the same view. And there is no actual standard that I'm coding for, right? It's just what I decided when I made these, right? And the truth, like if you're looking at Berkeley's NERSC's dashboards, they're going to look different than mine because I haven't been able to share them because my data is still different than theirs. So when I think about quantum, right, well, we have the IQM. We also are currently have quantum brilliance. We have the QCup machines that are all on the cloud. If Michael, looking at it from user assistance, or ideally if the user could look at, this is my job that ran on each machine, right? And they could look at that and understand the same information just by looking at a screen, they would be so much more like they would understand what their jobs are doing quicker. But that requires the vendors to talk and say, okay, well, did you say modality? I think sorry, I literally don't even know what it means. But let's say you said modality, right? So, well, your modality is different than ours, but we can present a similar thing that people can understand what their job is doing in this way, right? And I can't lead that discussion at all, but that discussion needs to be had for the sake of vendors and for the sake of researchers later to really understand how the machines are operating and what they're doing well, et cetera. In my opinion.
Yeah, I wanted to ask this question of the people in the audience. So if you go to slide 13 or one of the pictures.
One of these, okay.
Yeah, the data lake picture. So for example, at LRZ, so I think maybe Patrick or Mateus can talk about what happens at LRZ. Does this reflect what happens at LRZ?
I need to be fully honest here. I don't know.
Okay.
But I
No
can find it out. This is
okay.
Yeah.
Not everybody's going to go to Stream. Like not everybody goes to Kafka. That's not a standard. But
Okay.
I would say that everybody is going to have sources coming from everywhere, for sure. And then everybody is going to have some sort of near-term database. Like those are requirements so that they can look at the visualization.
Okay.
Moon, what were you going to say?
So for LRZ, we have Michael Ott as our constant collaborator from that laboratory. So he operates on top of MQTT, DCDB, Cassandra, those databases. He doesn't have a archive, I think. But the architecture looks very similar. So what we call this is like an hourglass architecture. Kafka Stream is this one place where everything converges and then it just goes out to a different consumer base. Everything else can be different, but that hourglass architecture itself alone is something that we see as a pattern almost everywhere.
I see.
Yeah, and QTT is the one that they use as the bus, and then sensors go into that because it's a standard format that a lot of people can use. So it's distributed in that way, and the downstream databases can be different based on the need, and vice versa. But yeah, Michael Ott, he's been, I think there's a working group, he's the technical lead there. He's the one who talks about these hourglass architecture. Implementation is all different. It could be Kafka, or it could be something Victor metrics serving as that purpose, if you will, architecturally. It's converging and then a bunch of consumers downstream. So I think you can find that pattern if you start talking with people. Yep.
Okay.
One other thing I wanted to add about Tim's comment about vendor comparisons and getting the vendors talking. It's interesting. Just I'll say not a lesson learned, but just something we see in QCup right now is that the superconducting vendors that we partner with, so IBM and IQM, are pretty nice at displaying machine information to users. So if you go to their cloud dashboards, they typically like, here's the connectivity, here's the timing of this qubit, that qubit, here are the error rates and things like that, and are good at exposing that data. However, our ion trap vendors, and this is not me throwing under the bus or anything like that, but it's very limited on what they show users through their dashboards. I don't know if that's a historical reason or just something they haven't thought about, but it's interesting, at least right now, of how it's split a little bit. So it'd be interesting to pick brains of the ion traps to see what they're able to share as well, and which I know that would be the plan, but I just wanted to give some thoughts on what we've seen so far in QCup for what we worked with.
Doug has his hand raised.
Yeah, just a quick question. Does open telemetry fit into this anywhere, or has anybody looked at that as a potential standard for the format of the metrics?
Moon, do you want to answer that one?
So honestly, we have not looked into open telemetry. But there's a little bit of so there are different levels of places where you can implement a standard, I think. And I think you guys have been working on this one, so you guys know much better than I do. But it seems like the format itself is not really the problem. It's just like what kind of metrics the system actually exposes. Because end of the day, it's the firmware and the engineer who knows nothing about the user journey. But end of the day, what he or she built for bringing up that system eventually ends up being something somebody wants. So the real discussion is like really linking use case is really the king here. Standard I think is the secondary thing because really it takes time to get there. But use cases are the ones that really defines that. Just enabling this end-to-end understanding of, oh, this will end up here for this particular use case. I think establishing that will be much more important. And at that point, I think whether it's open telemetry, whether it's what is it? Other format, I think it doesn't really matter that much because number one, Tim will like definitely adjust as you go. And these days we have AI, like format conversion is getting cheaper and cheaper. It's kind of a trend I think I see. So everybody's going to turn into R2D2, pushing their arms in and converting stuff. But like the real problem is not being able to pull the right data from the right sensors at the right quality at the right time. And so just coming up with a good set of items that you can expose to achieve a workflow or achieve a use case, that's I think what really matters. And because like standard can be really expensive to maintain. And then for example, let's say we have a next generation of modality, then what are you going to do with the already established metrics and vice versa and the format? Maybe there are ways to go about it. Yeah, that's not my expertise. But the way how he dealt with is really this kind of ad hoc, bespoke, like, investigation, but trying to make sure we talk each other end to end and the firmware engineer know that we care about that particular sensor he or she is implementing and making sure that exposes all the way up to the chain and exposes up to us as a product. That's what I think what really matters here. But yeah, that's just a sort of an excuse, a long-winded excuse of me not saying like we have not looked into open telemetry. The part of it is we haven't had the time to actually look into open telemetry, if you will. And many of the stuff we've been doing kind of predates that realm. Yep. But depending on where you are and what we're looking into, it may or may not be applicable to the thing. So I'll be interested to know how that would apply. Yeah.
Okay.
So I was wondering if we could hear from QRMI or QDMI, so Alex or Tani-san or Patrick or Mateus. I think the challenge from the interface perspective, and correct me if I'm wrong, is just making sure we could tie into this type of pattern, or even provide a very simple version of this pattern. What are your thoughts on this?
I mean, I think for the interface itself, it's just a matter of how to expose the machine information in a standardized way, right? Everything else then is handled by the pattern. And I also think that should be the scope of the machine interface and not more. We should not overdo that here.
I see. So don't go to a stream, or don't provide a delta, or don't provide the ocean. Always just make that outside of the interface then.
I'd say so. This seems for me the architecturally sane thing to do. Otherwise, you tie a lot of structure to the interface itself, and it's not clear at that point whether this is the right thing to do. So I'd separate the concerns here and just have the interface expose the information in a now quotation standardized way, which of course depends on how much information is exposed by the hardware vendor. But that should be the only concern of the interface at that point.
Right. Okay.
I agree with that.
I think you certainly don't want to open up all that information right through, and you don't want to make the kind of interface layer too cumbersome. But I do still think that we want to be able to pass through data in terms of the costing and things like that. Like if we're using QRMI to link between the quantum computer and the HPC center, then the HPC center will still want to know things like the accounting information, things like that. So I think we still want to pass through some information, but not all of it.
Okay.
From my experience,
doubling my role from both QRI and from the vendor perspective. No, I think what's missing here is the time perspective. Like we should think about what metrics we need at what time and for who will consume it. Like because we have the let's say we have resource management, we have the job management, we can have the device specifications, but then there's also other QPU data that our customers have sometimes wanted to receive that's, let's say, of no use whatsoever to an end user, but it will be just some ticker they can monitor to have a signal for whether or not the device is working properly or not, right? So that there will be multiple of those data streams coming from the QPU. Some of those might be useful to have in the RMI because they might pertain to the user in some way, or they need it for scheduling or to determine if the device can accept jobs. But others, I assume, they're just observability data, and I'm not sure if that should go, like, if the resource management interface is the right place for that. But I'm happy to hear people's thought on that.
Okay, good point.
I wanted to make a similar comment. For example, the status of the fridge, right? If you have a superconducting QPU, this is interesting, but it's not relevant for the scheduler or the sort of day-to-day operations. And then the question is whether you want to expose it via the interface. I see the charm behind having an interface which just abstracts all of the QPU, and the HPC can only query via that interface. But on the other hand, I also see the point of making it not too cumbersome, and sort of these two things. So we need to separate concerns here. which thing is interesting for whom and whether we should put this into one standard. And I don't have an answer to that.
And some of that data might not even come from the QPU, right? I'm thinking of this really nice paper from the LRZ people where they put sensors in every single inch of their data hole, right? And that is something you probably want to mix together with your QPU data. And you might want to consider where you're going to consume the data for where you're tagging it. Sorry.
Yeah, Doug Jacobson made
a.
Doug Jacobson from NVIDIA, I should start saying SCAD-MD, made a similar comment. He said the only data we're going to collect is the data that we need to make scheduling decisions. Everything else we don't care. So yeah, I agree with both Alex and Matthias. We need to start classifying things and go to different places. Oh, sorry, I skipped the line. Sorry.
Matthias is number one again.
Yeah.
No. I made my comment. Just continue.
Yes, put your hand down and.
Yeah. Sorry.
Yeah.
I think it's Greg.
Yeah, I think Greg is next.
Go ahead, Greg.
Hello, all. Have to get this off of mute. Yeah, listening to this, listening to this conversation, and I don't know if we've defined kind of what those user personas are now. So your operations and monitoring people might be interested in how much time the QPU is using to cool down or other metrics like that. But not really sure if that resource interface is probably the best place to publish that through. And the reason is there's gonna be a lot of that interface is going to be providing feedback to Slurm, feedback to LSF and other places that actually affect the user journey more than anything else. So I just if we try to put everything all in that single interface, my gut instinct is that it's probably going to become very bloated very fast and then not really be of much use to anyone. Just a thought.
Yeah, great point. Yeah.
Mm-hmm. Any feedback on that's welcome.
Greg, you mentioned about the personas, and I think my comment is exactly about that. It's Laura in the openQSE day, she shared a slide that is like a page in her slides where she talks about a publication that is coming up. Know your qubits, know your users, personas for quantum software. I think that could be helpful to establish some personas. Of course, it's not necessarily focused on workflow managers, but it could be a start.
I appreciate that. That probably will provide some good insight for me.
Yeah. I'm still waiting for it to be published.
I think in the meantime, you could probably reach out to her and ask for the slide. I remember she's definitely happy to share slides. And I remember the slide you were talking about, and I'm trying to find it because I swear I took a picture of it. But she'd be able to provide it.
Yeah, she mentioned that who to not publish the slides because it's the paper was not published yet. But we should be able to get a copy with her. Yeah.
Thank you.
I actually have it here. I'll go ahead and share it so people can see it. And then forget that you saw it.
Yeah.
We have a slightly different take internally, but this is not bad. I mean, it will be interesting to read the paper. I think Wong, I think you were.
Yeah, I just wanted to make a comment. I really love that So the persona thing, can you put that just once more?
Oh, okay, but
Yeah.
you had to forget
Because
about it.
there's a very interesting point here, and I totally agree with what Matthias said about the interface. Now, so the high abstraction to close the hardware that actually happens in operational data analytics, like left and right, like quite significantly. So close to hardware are operational people, so they don't really care about the interface. As far as it's really about getting the machine up and being able to diagnose, capture the data, send it to the vendor, be able to understand what's going on and do the good report. That really takes it to a degree that the interface doesn't matter anymore. It just will write scripts and collect anything out of it. So there's an interesting use case there. But at the same time, just like normal users like doing stuff where a normal operational situation, if the interface is really serving that part of the audience, then there's a certain set of things you just do very well, and you don't have to really care about anything else potentially. So like I need to learn a little bit more how the stack actually looks like and which interface serves which audience, if you will. But end of the day, I think it's about just weaving, like exposing the right information at the right interface all the way down to the device level. And I totally agree with the point where it's just making the collection less cumbersome is the most important thing, but you don't have to implement everything. So the data delivery, everything that will I agree that that's a responsibility of a different kind of architectural component. Maybe it's not here, but interface wise, being able to give the flexibility to all the way up to the embedded quantum devs or like the extreme experts, or just put yourself in that user journey. You're the vendor, but you want to have some field data. Just invest a little bit more onto that. And if we can collect those, if that really helps our operations, because so long term, because we are also interested in the long term behavior of these components in general. For example, like failures, then you can kind of like those will come as a good compound in the future investment. Return and invest in a way that it will give you insight of how these things really behave in the real world, if you will. So those are interesting things to think about. I think if you include that, then you can kind of reason about what you can do at each level, I think. So the quantum device level, I think there are a lot of things that really looks very interesting to me. Interface level, the resource management interface level, I think that's also very interesting. But the use cases I think quite significantly different. One thing I just wanted to inject here is, as far as there's a way to contextualize the data set with a unique identifier, whether that's a job ID or a workflow campaign ID or something like that, that would be really great because it will really help processing the data and really correlating things in general. Because one of the major use case here is, for example, we do collect a lot of environmental data. It's usually dead when you just look at it, but when the moment you contextualize that with the application, the project that it ran, then it kind of starts to get alive and do stuff for that information. It gives you a ton of insights for that, like what the user did there, how the system responded to that. So one other thing I do care is like, is there a unique mechanism to pass on the unique identifier from one layer to another layer that's seemingly very distant, but later can we do that and wrangle it together the downstream? I think as far as you do that, it doesn't really matter which interface does what, as far as you expose that information, if you will. Yep.
Okay, that makes sense. I was thinking about what next steps could be here, and I just wanted to get people's thoughts on this. So we have a better understanding of how Oak Ridge wants to consume things. I think we have a few opinionated implementations. I'm wondering if in one of our next meetings, we should have those opinionated implementations explained and then try to decide how they can be integrated with the Oak Ridge system or what's happening. Because Doug, I think this is something that you'll need to do with QFW, correct or incorrect? Doug, you still there?
Yeah.
Mhm.
I'm still here. Yeah, exactly. This is something that certainly on the benchmarking work that I've just started, I
Mhm.
would definitely want to try to make this work in the long run
Okay.
with all of this discussion. So that's why I started going down the path of open telemetry, but I'm now thinking, no, I may not want to do that right now. Pull back and have a look at the metrics like Victoria metrics and things that are already being used.
Okay. So perhaps we should plan on doing that for our next meeting. Let's do let's have a deeper discussion of what the current interfaces are providing. So perhaps Otani-san can talk about QRMI, Mateus could talk about QDMI, and then we'll try to figure out how we can expose them to Oak Ridge. And I guess in a couple of weeks, it'd be too early to hear about any real experience with the IQM system, right? Because that's still coming up online, or Michael?
Yeah, I
or-
mean, it's technically still going through. This is sort of the problem that I showed in my slides, where it's going through its like second stage of acceptance, even though it was vendor accepted. Now it's going through our science engagement team's acceptance. That being said, yeah, I'm not sure. I haven't been on the discussions with IQM about like the Grafana stuff at all. But that's up and running. But I'm not sure like what we can glean from it in that time frame.
Okay. So we'll hold off on that discussion. Okay, and then also maybe next time we can discuss the milestones as well. Okay, because we're out of time. So Tim, I'm glad we had the discussion now rather than during openQSE Day, because we would not have had a chance to really ask questions or have a deeper discussion. So I appreciate you giving us the talk now. Thank you.
Yeah, thank you for the time.
Okay.